I'm going. So we what we started this semester is XY coordinate system is also called Cartesian plane. And this is invented, that was invented by the famous French philosopher and mathematician is his name is Rene Descartes. And so he's a famous philosopher said, I think, therefore I am. So, but he's in mathematics, his contribution is the XY coordinate plane. Now, it seems kind of straightforward, simple invention, but it is foundation of uh, uh, for calculus. So without XY coordinate system, we won't be able to study calculus. So you can see how important that is. Without calculus, we pretty much don't have any thing like cell phones and computers and all that. Okay, so now we have XY coordinate system. So in order to graph something, we just need to find the coordinate. So for example, this coordinate will be 4 comma 4. We look down to the X. We got 4. Look to the left. Basically, we find 4. So 4 comma 4. Or if we have point here, we went down to the X. We see -4. Then we put a line to the Y, say 2. So this is -4 and 2. So the first one is always X coordinate, second one is Y coordinate. So with that, then we can graph things. For example, if we have a function Y equals 3X plus 2, this is called linear function. The reason we call function is uh, this equation tells us the relationship between two numbers or two kinds of numbers. One we call X, one we call Y. Both of them are called variables, which means that its value varies. It's not a fixed value. But X, we call that independent variable. So in a function, uh, this is a linear function. So generally, we use this one to express that y is a function of x. So basically, we use this instead of the uh, English sentence that y is a function of x, but it means the same thing. This is kind of nice thing about math. You can use very concise notations. And also it's universal. I mean, anywhere in the world, they understand if you write like y equal to f of x. But if you write that in English, there is a lot of people who do not understand it. Okay, so the x is called independent variable, and y is called dependent variable because whatever the x, y value depends on the x value and also depends on what kind of function. Like here, what is our slope? What is our y-intercept? And so that's why we call this dependent. Now, if we have this function, we can write just like here. This is the function form, but we can also graphing it, which we call that graphic representation. So how do we graph it? Well, in the XY coordinate, we just need we call that ordered pair. There's two numbers. So allow us to find the point on the 2D space. So now there's a different way of doing it. One way is to have a table then we just assign x a number. This is just up to us. X can be any number. But normally we'll pick x as 0 because that's easy. Then if you have 0, it's plug in 3 times 0 give us 2. So we find our first point. Now the second point, we can use 1. If we use 1, then y will be y equals to 3 times 1 plus 2, then give us 3 plus 2, give us 5. So we got 5. Or you could have -2 if you want. Then y will be 3 times -2 plus 2. Then we got -6 plus 2 equals -4. Now have 3 points. We really just need the 2 points to draw a line. But just give you 1 point, and to show that that's the case, we just need 2 points. The third one just redundant. Okay, we got 0, 2, which is here, and that is the intersection point between the y-axis and the line. So that's why we call this y-intercept. And the next point is 1 and 5. So we got 1. We go looking for 5. 5 is here. So that point, second point. So this is 1, 5. Then -2 and -4 is here. So -2, -4. Now, if you connect that with a ruler, I don't have that, but you can see that this actually going through all of that. So that's how we're graphing a line using the table method. Okay.
Could you re-add up to get the 1 and the 5?
What's that?
Could you re-add, re-figure out how you got the 1 and then the 5 for the x and y coordinates?
What do you mean refigure?
So for x you had it as 1, but how did you get y to be 5?
Well, 3 times 1 is 3. 3 plus 2 is 5.
Oh, okay.
Okay, just plug in the value for x.
Okay, yep, that makes sense.
Okay. So
Thank
now,
you.
yeah, no problem. Good question. So this is one way of doing it. We also learned a different way of doing this is we're just looking at the y-intercept and the slope. And you'll see we're going to get exactly the same 2 point as this. X, Y, 0, 2, 1, and 5. Okay, so if we use so this is our y-intercept, then our slope is 3/1. Now slope is always a ratio, but we can write as this. So that means our rise is 3, our run is 1. So the run is a horizontal distance. The horizontal distance is 1. The rise is a vertical distance, which is 3 and +3, so I have to go up. So this is 1, 2, and 3. And you can see that this point actually is 1, 5, just like we did here. Of course, this point is just 0, 2, and then we just connect them. Yep. Are we okay here? Yeah, very good, very good. And so there is a third way of graphing. That way is we're going to looking for not only definitely look for y-intercept point, but we also look at x-intercept point. So if I draw the same thing, well, just different color, then we can try that. So that way is we still use a table, but we set x equal to 0, then we know y is 2. And then we set y equal to 0. So then we're trying to figure out what x is. So this was just simple linear equation. 3x plus 2 is 0. So therefore, 3x equal -2. Then x is -2/3. So that's -2/3. And this one is the same. Then we can see that find the x intercept point is basically line intercept with x axis. And this point, you can see that it's actually just, if I draw that accurately, then I should get this negative 2/3. So was not very accurate. And I'm going to show you a different function because here we're dealing with fractions. Sometimes we couldn't do that as good as we wanted. Actually, we could do this. I want to show you the nice thing about this DOS. We actually can type in the function y equals 3x plus 2. They'll draw that for us. Okay, so it was pretty clear, close. If you're looking at what the drawing here, of course, I can get the y-intercept close. 1,5, pretty close. But on the negative 2/3, I was off a little bit. But if you can see here in the graph, if I go look at this point, and we can see that this point is negative 0.667, which is negative 2/3. So the nice thing about this tool, this is 0.2, and we got 1 and 5. So right here. Oh, just make sure I got clicked right. You can see that changes. Not exactly, because I got exact. Oh, yeah. Oh, I got it. Huh. It's up here. But anyway, here. You can see that. Good. So now we're going to, because we have this, then we can solve system equations by graphing. Basically, is graph the two linear equations and find the intercept. I'm going to show you example here. Let's take this out. So we got, say, y equals, so normally when we say system of linear equations, we kind of use this kind of form. Of x plus y, say, equal to 1. So this form is called standard form. So there are basically three ways of describing a linear equation. This is standard form. We also have this form. We did that early on. That form, this is called slope, intercept form. Then we have y minus 3 equals to, say, 2/3 x minus 1. This is called point slope. So when we're dealing with linear equations, we just have those three forms we're dealing with. And this is pretty simple. I mean, we got the slope, got the y-intercept. Now here we have the slope, then 1 and 3, 1 comma 3, that's a point on this line here, because when you're graphing it, you'll see that that's a line. And this is a point that goes through. So that's why I call point slope form. So now we have system equations. That means we got when they are separate by itself. Now the solution for the top is infinite, and solution for the bottom is also infinite. But when they intercept, then x and y is fixed. They are no longer variable. It's something we call unknown, because this x and this x is the same, this y and this y the same. Should have exactly the same value. And because that's what we mean by using this symbol, say those two equate, whatever the solution has to satisfy this equation and also satisfy this equation. So if you have two lines, we have intercept point. So this point satisfy this line, also satisfy this line. So that's why we call the solution for the system equations. Okay, how do we do this one? And normally we just using lookup, just have a table, but we can also say change this one into y equals to negative x plus 1. So that's the point slope form. Sorry, point intercept, slope intercept form. We can also do that. Okay, let's use just a table form. So on the first one, xy, if x equal to 0, then y will be 7/3. And if x is, so I'm going to use xy intercept as to graphing it. So I find the y-intercept. X-intercept is y equal to 0. If y is 0, then x is 7/2. So where is that? 0, 3/2, 7, which is 2 1/3. And we got 2. This is 3. 1/3 is somewhere here. And when y is 0 on x, so 2/7, that's 3.5. So we look at 2, 3, and 3/pi here. So we got line like that. Oh. And on this one, so if x is 0, then y is 1. If y is 0, then x is 1. So we find the 0, 1, which is here, and 1, 0, which is right here. Then we draw the line here. And you can see that we intercept somewhere along this way, along here. So there's a negative half and comma something. Okay, so now I'm going to use this program to help me because it's very hard to graph it accurately. So I'm just using that. And you can just type the equation here. So you can say 2x plus 3y equal to 7. And you can see that just went over what am I joining there. And x plus y equals to 1. Look at that. So I'm off. So point should be somewhere here. And so when we're actually doing this when you do homework, so that's our solution, -4 and 5, and it on both line there. So when you do that as homework, you should use graphing paper and also a ruler to get it kind of as accurate as you can.
Are we allowed to use this app for homework?
Well, on homework, actually, I would suggest you just using graph paper and the ruler, so you get a feeling for that. So,
All right.
yeah. Okay, and we can check and see if that point is a solution. Basically, we can plug in x is -4, so -4, y is 5, -4 plus 5 is 1. That's good. On this one, 2 times -4 is -8. And 3 times 5, 15. -5 plus 15 is indeed 7. So we can check on both. So that's the way we know this is the right answer. Okay, are we good? Yeah, you can use this one to verify. If you graph it out, then just use this to verify it and see if you got that right. This is a nice thing about when you have those kind of programs. You can do the same thing with inequality. Let's say if I want to do inequality, I can do a y is less than equal to 3x plus 1. You can see that everything under the line shaded. Then I go another one. Y is greater than negative 2/3 and x minus 3. Okay, so you can see that they graph those two, and you see this is a dotted line there, and our solution will be the overlap, which is from here to here. You can see that those two overlap. Okay, are we good on this one? Thank you, Eddie. Thank you, Matthew. Very good, very good, very good. Okay, I'll let you doing couple of those works, and you can just do on a graph paper and the ruler and see if that, then I'll verify on your answer by just using this program. Okay, let's do this. Y is greater than or equal to negative 3x plus 1, and y is less than 4/5 x minus 3. Okay, let's see what you got. All right, I'll give you 5 minutes on this one.
Do we need to get graph paper?
Yes, use a graph paper and the ruler.
Okay, I'll be right back. I gotta go grab some.
Yeah, no problem.
Dr. Pig,
Mm-hmm.
I don't have graph paper. Can I do it on an online graph paper?
Yeah, you can.
Okay, thank you.
Yeah, if you're done, could you give me a thumbs up? Okay. Hey, Eddie, you need more time?
Yeah.
Okay. Okay, well, let's see what we got. Greater than or equal to negative 3x plus 1. And then we got less than 4/5 x minus 3. So now if it's what you have, could you give me thumbs up? Thank you, Eddie. Matthew?
No, it's not what I have, but it's similar.
Okay, so are you okay with this line?
Yep.
How about this line?
Well, so I have it going directly to the 2. So I might be correct. Yeah, you know what? I think I am correct. I just put it right at the 2 instead of down a little bit.
Okay. Yeah. All right.
That's what I got too.
Oh, what's that?
I got the same as him.
Oh, you mean,
Like it wasn't touching the -2. It was just a little. It in my answer, it was touching the -2 line.
oh, this line?
Yeah.
Yep.
You mean you go like this, the graph?
No.
No, go ahead.
It it was in the same side, but it was in the same area as the point, but it was a little bit up for for me.
Okay. Well, let's see. For the first one, -3 plus 1, we start with here, right? Then we
Yep.
go 1, then go down by 3. 1, 2, 3 will be this point, right? Then we graph it. On the second one, we start at -3, and then R is 4/5. So our run is 5. 1, 2, 3, 4, 5. Then we go up by 4. So 1, 2, 3, 4. So it should be here when we graph it. Good.
Yep. And for what I did is I just put the -2. I put the line right through that -2 dot. I didn't move it down. I didn't see that it
You mean
actually.
you did like this?
No, so I made my uh, I somehow got mine to go straight, but it went through the -2. Like it was barely on the bottom of the -2.
Okay. Yeah. Do you all got the y-intercept right?
Yeah.
Yep.
Okay. So it's matter for the other point. Okay. Now, let's do just one more, okay? So this time we're doing uh solving system equations. Okay, just graph them.
Is this just like the first one?
It's like different. First one is in inequality, but the graphing is the same. The line you graph the line.
Oh, okay.
The solution for this one just the intercept point. Okay.
Okay.
Dr. Plain.
Mm-hmm.
So I got the graph, but I only have one line. Is that gonna be the answer?
No, it's going to be two lines. One is going up, one is going down.
Oh, okay.
All right. Okay, Matthew?
Yeah, I'm not quite sure exactly what I did, or maybe what I'm supposed to be doing.
Oh, let's see. Now, do you get this line correct?
No, I didn't even get to the graphing part. I'm still trying to figure out the problem.
Well, this is the same. We just find 2 points when we're graphing linear lines. So if you from this one, x, y, and it doesn't matter which 2 points you're going to put on. So I'm just going to use the xy intercept method. So I set x to 0, then y will be 3y equals 10. So y will be 10 over 3. And I can set y to 0, then we got 2x equal to 10 because this is 0. So that means it's 5. So those 2 points give me so this is 0 and 5 comma 0. And this point basically is 10 over 3, which is 3 1/3. You can see that this is a 3 here, 3 and 1/3. Good.
Yep.
So then the other one then will be 3x minus 2y equal to 2. That'll be that line. Yep. Do you got this one? So Addy got this one. How about Matthew?
No, I don't think so. Well, no, I didn't.
Okay. So the same thing. We just said when we set x 0 for this line, we know it become negative 2y equal to 2. So y will be negative 1. So this is negative 1, which is this one here, y-intercept. And if y is 0, then we got 3x equal to 2. Then x is 2/3. You can see it's right here, that point. And our solution is the intercept point, which is here, 2 comma 2. Okay, Addy, did you get this one?
I was close, but no.
Okay. That's good. Close is good enough because when you're graphing it by hand, that's can be a little bit tricky. All right. So I'll see you guys next week. Okay.
All right. Thank you.
Yeah, I'll send out tests this week and just make sure you do that before we meet. Okay.
Okay.
All right. See you guys.
See ya.
See you next